Hello, this is Dr. K. In this video, we're going to talk briefly about sensors on smartphones. What are they, what do they do, and how many are there? For this presentation, I'm going to be drawing mainly from 3 different resources, all of which you can find on the web. The first is an article by Gizmodo, all the sensors in your smartphone and how they work. And a bit of a spoiler alert here, this article does not cover all the sensors in your smartphone, but it is a nice overview of some of them. The second source is a question on Quora, which is how many different sensors are available inside a smartphone. As of this writing, there are over a dozen answers to this question, and at least one of those answers lists over 30 different kinds of sensors that could be available on your smartphone. Although I highly doubt that many of you have a Geiger counter in your phone, unless you're living in Japan in the vicinity of Fukushima. But if you are living there, it makes sense to have that kind of phone. The third source is a presentation from a computer science class at Stanford University. It's probably the most theoretical of the sources. It actually talks about things like what a sensor is and what constitutes a good sensor rather than a bad one. And that's what we're going to start with what a sensor is. A sensor is a device that measures some physical quantity and converts it into something else, like a signal. The signal can be read by a program, another device, or even a person. The key here is that a sensor interacts with the physical world. It is not a piece of software. You may have software embedded in your sensor, but the sensor itself measures a physical property. Most sensors today are electronic, so the property is typically converted to some type of electrical signal. Some examples of the sensors we encounter in everyday life are thermometers, radar guns, red light cameras, automatic door openers, and scales. Even before mobile phones were considered smart, they had sensors. A microphone is a kind of sensor, and you need a sensor to determine when a button on a number pad has been pressed. With the introduction of smartphones, the number of sensors in mobile phones has exploded. Not only do we have microphones, but we also have cameras. Not only can we respond to number presses, but the entire screen is touch sensitive. When Steve Jobs introduced the iPhone in 2007, he bragged not only about the touchscreen, but he also talked about 3 really advanced sensors that were built into the phone. The proximity sensor, which turned off the touchscreen when you brought the phone to your ear, the ambient light sensor, which dimmed the screen when it got darker to save on battery life, and the accelerometer, which detected whether the phone was in portrait or landscape mode. Sensors in phones have upset markets. Dedicated GPS makers like Garmin and TomTom have been affected negatively, as have camera makers for both still photos and video. What are the qualities of a good sensor? Well, it should only be sensitive to the property it's trying to measure. For most sensors, this is not a big problem except when it comes to temperature. When it's too hot or too cold, a sensor can return faulty information. A good sensor should not influence the measured property. For example, if you drop a mercury thermometer that is room temperature into a glass of hot water, the thermometer will actually cool the water slightly as the mercury absorbs the heat. That's not good because you wanted to know the temperature of the water without the thermometer. A good sensor should output a signal that is linearly proportional to the measured value. That means if you graph the signal with respect to the property, you should get a straight line. If it's not linear proportional, you should at least get a signal that's a simple function of the measured property. Finally, a sensor should have good sensitivity. If the sensitivity is too low, it can be difficult to detect small changes in the property being measured. A bad sensor will often exhibit drift or noise. Drift occurs when the signal changes independently of the measured property. This can sometimes be fixed by calibrating the sensor. Noise is just random deviation in the signal. Sometimes noise patterns can be detected and filtered out by signal processing techniques, but doing this can take time and consume power. And speaking of power, when it comes to mobile devices, we don't want sensors that consume a lot of power. Likewise, we don't want sensors that cost a lot of money. Remember, when it comes to computer hardware, making things smaller doesn't always mean it's going to cost less. In fact, smaller components are often more expensive.